Okay, so our last step in working with vectors for now will be to basically solve word problems using what we've seen. I'm going to go over number 12a here from section 4.4 as kind of the introduction to solving problems. Now, as we've said before, I don't want to give you a prescription as to how to do math. It's always kind of a matter of you thinking through things. So I'm going to go through this in two different ways and just kind of give you my thought process as I go through. Every question you run into is going to be unique in some way. And so your job will be basically to set up the problem before you start working on it. And then the actual solving of the problem will be just a trig problem. So this question saying, calculate magnitude direction given F1, F2. And here's some details about F1 and F2. So each part was a little unique. In this one, I'm given F2, I'm given the resultant, and I don't know what F1 is. So that's sort of why I have it drawn the way I do. F2 is on a bearing of 48 degrees. And I put the little bearing diagram over here from the notes, just to remember that 0, 0, 0 is north, and then basically we rotate towards the east from there. So 48 degrees is a little bit more than 45 degrees from the vertical here. So I'm just going to look at a simple little axes. And it's somewhere in that neighborhood. Now, as I've said before, I'm not going to be concerned about drawing everything to scale, but getting closer to scale will help me visualize things a little bit as well. So something nearing 48 degrees there. And then the resultant is something nearing 100 degrees here. So 90 to there. It's not very good. This is probably closer to 130, but the idea is still the same. Now, two possibilities, I guess, going forward. The first is that I can draw this so that my F1 and F2 go tip to tail, and then my resultant kind of falls in from the tail of F1 to the tip of F2. And I can do a little bit better job. And knowing that those two are relatively accurate, I can adjust this one as I need to. I better ungroup that, I guess. And so this ends up being my diagram, basically. Now, the information I know deals with the coordinate axis here, the northeast, southwest axes. I know that F1, F2 is 100 degrees coming around from here. And so I have to use that information. And then, of course, the idea that down here I have a kind of a 48 degrees involved. I'm going to use that information to figure out what one of the angles or what some of the angles are on the inside of my triangle. I've got probably a few different options. The first thing to note is even though the way I drew this, F1 looks like it's almost vertical, that's just kind of coincidence. So I'm actually going to change this so that I don't confuse myself into thinking that that's what I had. I have no idea really what F1 looks like. I just drew it in based on my fairly decent drawings of F2 and F1 plus F2. And so obviously if I drew things kind of like this, where again, not really to scale, but not too bad, you should be able to tell that F1 is not vertical here. So I won't use F1 in any way to determine what my angles in my triangle are. The 100 though I do know, and given that 100, I can say that I know there's basically a 10-degree angle on the inside here. Now, that coupled with, if I put another one of these over here, will allow me to say that a 10-degree angle in here means that I'm going to have, because of the nice little Z rule here, I'm going to have a 10-degree angle right there. Same sort of thing down here. I have a 48-degree angle across to there. But again, that's not actually in my triangle. You can see that with the blue line here. It doesn't quite come straight down on the north. This angle right here, though, which deals with directly east, and one of the lines for which I actually have information, this angle in here is 42, which means that if I follow that Z pattern up again, I will have a 42 in here. And now essentially I have this triangle with 110, 52 degrees, and 120 down here, and I need to solve for the missing length here as one of the two parts of my question. The question actually asks me for the magnitude, so the size of this, as well as the bearing. I'm going to pause the video and do those calculations. I don't think that's something you should have to watch, and then I'll come back. Okay, so slight change to what I had drawn, just color-wise here. I kind of went with the colors of our Z patterns. So the same diagram again, 110, 52, and 120. If we want to solve for the value of x, the unknown value over here, it's a cosine law. Anytime we have side, angle, side, with the angle being trapped between the two sides, we have a cosine law, and you should be able to follow that okay. C is 101.2. From there, so that's the magnitude, we need to find the bearing. And so using the same variable listing or identification here as here, this is my C side and my C angle. This is my B side and my B angle. Again, how you label them is completely up to you, but that's sort of how I had labeled them in the previous example. So to find the angle, use the sine law, rearrange, and we find 69.1 is that angle. So 69.1 is that angle in there. Now, finishing up, we want to recognize that's not our bearing though. That is the angle between those two vectors there and there. We also know that the 110 here, or sorry, 100 here, there is 100 here, I guess what I'm trying to say. And so what that means is, if I was to try to do a little bit better job here, I have 100 plus 69 more. I guess this line actually should be coming out this way instead. Again, no problem for our calculations, just sort of to visualize it. There's 100, then 69.1 more. And so to determine our bearing, we want to make reference to either that full distance around, or if we're doing the other style bearing where this would be south and then a certain amount to the east. So the bearing looks to me to be 169.1. So therefore, I guess we'll just say that F1 is 101.2. I think these are newtons. I don't even remember what the original question said. Newtons. Bearing is 169.1. And of course the alternate bearing would be referring to this angle here. So the alternative here would be or south, and what's that, 10.9 towards the east. Now this is the bearing I will tend to use because I think it's less confusing. Standard bearings going from north is kind of confusing in math class, where we usually call this a 90-degree angle going from the x-axis towards the y-axis. So we will stick with these bearings most of the time. You should be able to adapt in the questions, but on a test, I think I'll be happy to say we'll stick with south towards east, south towards west, and so on. Okay, so I'm not going to solve this question again, but I'll sort of set it up a second time. Because this question was in the subtraction section, we do have an alternative way to go through this, and I guess we would anyways if we had the same information. We could treat it like a subtraction, and of course if this is, if vectors f1 plus f2 add up to this, then vector f1 plus f2, vector 3 if you want to call it that, minus, I guess I could write this down. So for our purposes, maybe I'll call this F3 instead. And if we know that F1 plus F2 equals F3, then of course it's safe to say that F3 minus F2 would equal F1. Okay, and so if you tried the question that way, certainly that's okay. Probably again, that's what the intent was in this section, although to me you're going to solve this problem however you're going to feel comfortable doing it, and that's whichever way works best for you. So here I've got my F3. To subtract my F2, I need to reverse it, or find the opposite of it, I should say. And then basically I'm going to take this one and add them. Okay, so this is what we've been doing. In order to subtract two vectors, we add the opposites. So really now I've got F3 plus the opposite of F2. That will allow me to solve for the F1. You can see that it's more or less in the same orientation as I had predicted, although we know from before that it was off somewhat. And then given the fact that we know the information about F3, the information about F2, we can determine what those various angles are, and of course we should end up with exactly that same 52 here again. So the same arguments would be held for the F3 as was the case right here. So I'm going to end up with that same 10 in here. And then this one, the 120 was on a bearing of 48. Don't want that. Okay, so the F2 was on a bearing of 48, which means that if we extended it, we would have a 48 up here. And given what we know from various line rules, 48 up here means we would have a 48 in here. Okay, so opposite angles, which means that we would get again our 42 here. The 10 would be determined exactly as it was before, and the rest of the question plays out the same way. Okay, so just wanted to sort of clarify that in case you had tried subtracting, thinking that we were in the subtracting area. Of course, it does work out. You will use whichever method is best for you given a question. Usually they probably aren't going to be worded this way, where you start with your resultant and you work backwards, but if you do think of it as subtraction, that's fine. Or think of it going forward as an addition and just with an unknown value and then work it out. You will get the same answer.